Assalamualaikum and welcome back to our lecture on structure stiffness metric for beam. We're going to continue for our example on problem 1. We need to determine the direction at the support of the beam as shown in figure below. Previously, we already identified numbering for our displacement, which is vertical displacement and rotational displacement, as we can see in here. Next, we need to assemble member stiffness metric by using the metric as you can see in here. Now let's do for member 1. Member 1, length is 2 meter. Then let's refine this value first. So for K1, small k, we know the constant value is EI in this metric, so we take that value up to make our calculation is easier. So we need to find this value first in this cell. For that one is 12 EI divided L power of 3. Therefore, 12 L power of 3 is 1.5. So 1.5 here. Do the same for the rest of those value. So we will get 1.5 here, negative 1.5, 1.5, 2, negative 1.5, 1, 1.5, negative 1.5, and 2. It is enough if we just did for the half side. The rest easily we copy it. And don't forget, for member 1, the numbering for the metric is near y, near z, followed by 4y, 4z. Therefore, numbering for our matrix for member 1 is 6, 4, 5, 3. 6, 4, 5, 3. Now for member 2. Length is 2 meter and matrix number for K2 is 5, 3, 2, 1. 5, 3, 2, 1. Let's calculate member stiffness metric for K2. Since length is same to member 1, definitely matrix value is similar to K1. So easily we just copy it from K1. Once we done our member stiffness metric, we can assemble for structure stiffness metric. For the numbering of our metric, we know we have 3 nodes, so the numbering start from 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have to find out what is the value for cell 1, row number 1, column number 1. Refer back for member 1 and for member 2. So 1 is here. So value is 2. So 2 in here. Do the same for the rest of your structure stiffness matrix. And we will get 1.5, 1, 0, 1.5, 0, 1.5, 1.5, 0, 1.5. Here is D1, D2, D3, D4, D5, D6. And this one is Q1, Q2, Q3, Q4, Q5, Q6. Now we need to find this line between D unknown and D known. Back to our numbering. Certainly, we know there is no displacement at 5 and 6. Therefore, D5 and D6 is D known. D5 and D6 is 0. Therefore, we can find the line between D unknown and D known. This is line between D unknown and known. Automatically, this the line we need to find out. Automatically, Q5 and Q6 is Q unknown. Q1, Q2, Q3, Q4 is Q known. Now let's find out what is the force for Q1, Q2, 3, and 4. According to the question, there is no other force or load except vertical force 5 kN against the direction of 2. Therefore, Q2 is -5. The rest is 0. So Q2 is -5. Q1, Q3, Q4 is 0. Not to forget the vertical line to split between unknown and the known. From here, 1, 2. So from here, 1, 2. So here is the vertical line. From our capital Q equal to KD, we can extend into two main equations, which is QK and QU, equation 1, equation 2. Now let's find for the first equation, QK. Assemble back those matrices for QK. We will get as below: 0 0.5, 0, -5, 0, 0, 2, 1.5, negative, 1, 0, negative 1.5, 1.5, negative 1.5, 0, 1, negative 1.5. This is very tedious work. Be careful on negative and positive sign. It's easy to make mistake on that. So this one is D1, D2, D3, D4. And for this one, we know our decay is 0. Automatically, value for this matrix is 0, 0, 0. From here, we can get 4 equation and 4 unknown. Therefore, you can use simultaneous equation to solve and find what is D1, what is D2, D3, and D4. As mentioned in previous lecture on trust, I did mention about matrix operation, which is how to multiply between two matrices. We only able to extend the matrix if our matrix size 2, 3, 3, 4 is matched on here. Then for the result, we can get from this value. So this is the result when we multiply two matrices. In here, you can see how the matrix operation. For example, we take this one between 1, 4, and 9, 6. First of all, -1 times by 9, then plus 4 times 6. So the value is 10. And this is the final answer for that matrix operation. Also, from this matrix, we will have 4 equations. For example, we can use matrix reduction method to find what is the unknown value. For example, we have here 3 equations, first, second, and third, which is the unknown value is x, y, and z. Therefore, by using row operation method, we can find what is value x, y, and z. Please remember, value here is 1. And finally, from this shape, you know what is the value of x, y, and z. Here is row, here is column on your matrix. For example, for matrix operation, on the how to multiply the matrix, we take for K12 times dk. K12 is this one. This is matrix K12, which is size for that one is 4 row times 2 column. Then for dk, this is our dk. The dk size is 2 row 1 column. Therefore, result for this matrix operation is 4 times 1. 4 times 1 matrix size. That's why, since we know our decay is 0, therefore the matrix size of 4 times 1 all 0, as we can see in here. And this matrix size is 4 times 1. You can use simultaneous equation, or you can use row matrix operation, and we will get our value. Solve it, and we will get D1 is negative 16.67 divide EI. D2 is negative 26.67 divide EI, and D3 is negative 6.67 EI, and your D4 is 3.33 EI. And checks what is the unit for your displacement. So we done on displacement for our beam. Now let's do for the second equation, where we can find those forces. Which is Q unknown, force unknown. Refer back what is your QU, and we fill up this matrix. So this one is Q5, Q6, and matrix for Q21 is 1.5, 0, negative 1.5, 0, 0, 1.5, negative 1.5, 1.5 times by D1, D2, D3, D4. And we know our decay is 0. Automatically, value for this matrix is 0, 0. Solve this equation. It's up to you how to do that. You can extend, and you will get two equations with two unknown. Then you can solve it. Either you can solve with calculator, or you can use row matrix operation. And finally, we get our Q5 and Q6. Q5 is 10 kilonewton, and Q6 is negative 5 kilonewton. So we done solution for this example.